In this example, I compute some descriptive statistics. We've seen the raw distribution, and we'll go back to our height example. Here's our little graph. And we have our distribution of males and females and the total that is the little dotted line in there. Now, one thing I did with this spreadsheet is I added a cumulative distribution for some examples that we'll talk about in a minute here. Notice that this cell right here is it's at bin 53. We go and we highlight the female. There's one female. And then this next cell, so we set this value equal to E6. In this cell, we take G6 and we add E7. And so forth. Down here, we take G7 and we add E8. Once you've started this, you can just do the little trick with the little square cross there and just copy down. And it automatically copies all those formulas down. Next, so this gives us the total number, but it's sometimes nice to have the proportion, or the percentile. So there's 60 females, so we divide this number 1 by 60 and 1 by 60, and then as it comes down it accumulates, and you can see we get figures that accumulate down to 1. Same way with the males, we go from 0 and accumulate down to 1. If we come over here, we can look at the graph of this. This is what the chart looks like. So females start coming up about, well, their first one's at 53, and then not too many till you get just about 60 inches, and then it has a nice sharp increase. Males take off a little later. If we look at, so let's look over here, we see at 70, this is our bin at 70, we've accounted for 95% of the females at the point where we are at about half of the males. So let's look at that over here. At 70, we've come to about half the males and 95% of the females. If we wanted to clean this chart up a little bit, we'd right-click, format the axis, make the top 1 instead of 1.2. It can't get to 1.2. And other things we might do is come down to number, let's see, that's down here, and just give ourselves maybe 1 decimal point. Alright, now we have this nice little graph, and we don't really need it, although we could come in here and type height, cumulative height. Alright, now let's calculate some descriptive statistics. So these are just functions, simple functions that you may already know. We come down here, I like to leave a space. We're going to calculate the mean. Now the mean in Excel is called average. That's a little loose on the definition. I click up in this first column. I do Control, Shift, and up arrow. That takes me to the top. Close my parenthesis. And I have the mean. One thing that I would like to do, it's very annoying as you go down and you lose your top, you lose track. We're going to come over here. Actually, we'll come over here in this cell right here, and we're going to freeze our panes. I'm going to go View, Freeze Panes, Freeze. Now, when I go down, I still keep the top. And when I come over, I can still see the frequency there. So let's Control down arrow. There's the average. Now let's do the standard deviation. That's equal STDEV parenthesis. And we come up here, do these guys, close the parenthesis. There we have the standard deviation. We're going to want to count the standard error. We'll get into that fuzzy little thing we'll talk about later. But in order to calculate the standard error, you need to know how many observations you have. So we're going to do count. I mean, we could just count them, but this is a little bit better. And count will count everything that's not blank. If we got rid of that 64, we'd have 59 observations. And then the standard deviation, if you will recall, equals the standard error is the standard deviation divided by the square root, SQRT, of n. And let's insert a column here. Let's call this the mean, SD, N, SE, standard error of the mean. Now, we would like to do a confidence interval. We're going to talk about these later, but might as well go ahead and calculate it here. And in order to do that, we're going to use a t-distribution. So we need to find the value for the t-distribution. So we want the 95th percentile. And so that's going to be actually the 5% interval. So it's inv dot t equals inv t, there we go, t inv, turns the left tail, tab, probability is 0.0. This is always tricky because it's different whether you put in 5%. We want a two-tailed test, so we're going to have 5 degrees of, or we're going to split the 5% on both edges. We're going to try 0.025, and then the degrees of freedom is the count minus 1. Let's see what that gives us. That's probably right. We can, that is the t-distribution for 95% confidence interval. So what we're going to do is now the lower limit, lower confidence interval, 95% CI, is equals the mean minus our t-distribution times the standard error. And the upper 95th percentile is the mean plus the t-distribution value. This is like the z-score, like, you know, it's 2 times something. The standard error. Oops. And okay, something. Oh, okay. It gave me the left tail, so it's a minus. So that's actually the upper. I added a minus. And this is the lower. So if we look at that, it makes sense because the mean is 64, 63 is less than 64, 65 is more than 60. So our best estimate of the mean is that our confidence interval has, if we did this an infinite number of times, we would overlap the true mean 95% of the time with this confidence interval. Now, the reason I typed in the count, or used the count, is so that I could copy these, bring it over here, and paste. And now we get the new N of 36 males, and these are all the means and the standard deviations and everything. So you can see the mean for men is a little bit higher than the mean for women. There are standard deviations. Actually, the men are a little narrower. That's because that person that was 53 inches, she kind of brought the distribution out a bit. But we use these figures to understand the nature of the spread of this graph. So that's some descriptive statistics. There are others that we could do. For example, we could look at the median. That equals the median of this. And the median's the 64th or the 50th percentile, and you can see 64 is the same as the mean. Let's just copy that guy over. Wow, that's pretty symmetrical distributions where the median and the mean are the same. That won't always happen. All right, that's it. Some descriptive stats.